Okay, so we got f of x is equal to negative 5x plus 6. So we're talking about f of x minus f of a over f of x minus a. Now this is kind of like your your difference quotient, except it's f of x minus f of a. And what are they giving you right here? What are they giving you? What's that point? Now we could do this with the difference quotient.
Would it not be plugging in negative 9 is equal to negative 5 but times 3?
Well, remember, remember your got 2 points, and you know this is x, and you could call this a, I called it h, and this right here is your, x of 2, this is your x of 2, right, and it's x plus h, okay, so what they're saying here is kind of the same thing. It says use the definition of this to find the slope of the tangent line to the graph of f at t.
Oh,
okay, this is the point. The point is 3, negative 9. Okay, that's your point. So you got a point at 3 and negative 9 down here. They're giving you a point on some curve or some whatever. It's down in the 4th quadrant. And you can figure out the y. If you plugged in 3, negative 15 plus 6 is what? Negative 9. So this is your x, and this is your y. So they're giving you that much information. So what are you supposed to do with it? So go ahead and work on it for a second. So what do we do?
Plug the x of the point in for a, and then you solve to figure out what the equation for x is. Right. So you take like 3.
Well, if you plugged in 3 for x, you plug in negative 9 for y, which is f of x. Right?
Yeah.
Because that's what I just told you, that negative 9, but you got to relate that back to negative 9 is equal to negative 5 times 3 plus 6. We already obtained that. That's from this right here. So what do you do with this right here? As x approaches a, well, what is a? I'm sorry, what?
Is it y?
It looks like to me they're giving you the difference quotient. It looks like to me, only they're giving it to you in different form. I'm going to do the difference quotient, and I don't know what they're doing, but let's see what they're doing. So that'll be negative 5 times parentheses. And of course, this is one of those DA questions that doesn't have an explanation with it. Isn't that convenient? 5 plus 6 minus brackets f of x is negative 5x plus 6 all over, and in this case we're going to do h. Okay, I think they're using a different nomenclature, but we're going to go ahead and do this. X plus h. So that's going to give you negative 5x minus 5h plus 6 plus 5x minus 6 over h. And that's going to be a 6 and a 6. And the 5x's cancel. And that's going to leave you with negative 5h. So negative 5 is going to be your slope at that point. Now, I think that's what they're asking.
Is that not just the derivative though?
Yes, that's the derivative. But see, we don't know the derivative yet. This is 3.1. We don't find the derivative until 3.3.
Oh,
So what they're doing in 3.1 and 3.2 is they're showing you how to do it with algebra and the limit theory. So as the limit approaches, as h approaches 0, your limit's going to be 5, -5. So your answer should be -5, but I don't know what they're doing with the x and the a's.
I mean, could you not gather though, from where you originally, the original equation, it's -5.
You don't know what the derivative is.
Oh, I'm sorry.
It's 3.3. You're in 3.1.
Gather what you're saying.
See, in retrospect, you got to think. Yes, you can go back and say -5. Yes.
Okay, I'm sorry.
Okay, that's
But the
fine.
slope of the
Everybody
line-
does that. Who else did that? Mr. Castles, was that you or was that Ms. Gusmus?
I'm Gusmus. I'm just
Okay.
saying, like asking if the slope of a tangent line is technically the derivative.
Yes, that's what we've been doing. Yes. But
Okay.
3.1 and 3.2, you don't know your derivative laws yet. You're doing it by
Right.
algebra. This is the algebra, the difference quotient. That should be your answer. I don't know why they couldn't tell you to just use the difference quotient. I don't know why they had to rewrite it like that.
Yeah, it was weird. I did this question. I had to do the guided thing with it.
Yeah, well, this one don't even give you an explanation. It changes it, and then it says, guess what? You're on your freaking own. That's what it says right there. Everybody's read that? You're on your own. So use your difference quotient and just ignore the 3 and the 9 really doesn't tell you anything. Because what is the slope of this line at any point? It's -5/1. So it doesn't matter. Okay? Is everybody good on that one? Yes or no? Just use
Yeah,
the
would you-
difference quotient.
Would you like me to explain the way that they use the limits?
What do you mean? Explain. Because
The way that they used it in this equation, because one of the problems that was on there ended up having like the explanation, and I figured out how to do it.
well, see, the limit as x approaches 0, it's not going to make a difference because there's no h in this formula. So it doesn't really matter what the limit approaches. But yeah, go ahead. Best way to teach is, best way to learn is to teach. Go ahead.
The way that I figured out to do it was you plugged in the f of x, and then for the minus f of a, you used x as a. So you plugged in to the original formula 3 for x, and then solved it that way. So
So 3 for x is going to give you -9.
Well, was she saying that you plug in the x for the a in the equation, and then you don't plug anything in for x. You just run the equation, and then it'll cancel the x's out through that equation, and you just get -5.
Okay, you cancel the x in one, you cancel the h's in the other.
Yeah.
Tomato.
Yeah.
Yes, I agree. Yes, you can do it that way. But they need to tell you that a is equal to 3, or they need to give you a little bit more than just throwing x and y in there. You see what I'm saying?
They were saying it was something like, I think it's where it says limit x is approaching a,
Mhm.
is where they got that from.
Well, then a would be 3.
In a different question, it actually does give you the help with this, but the first question doesn't for some reason.
Okay. If I was to give you a question on a test, it would be the difference quotient. Okay? Because 90% of the time, the difference quotient, 95% of the time, the difference quotient is what you're going to see other than the derivative. Okay? But thank you, was it Miss Gusmus or Miss Rowland said that?
Miss Rowland.
Thank you.
It's not a problem.
Did you do it by that, or did you do it by difference quotient x plus h?
I did it by difference quotient for a while until I figured out, like I went through the help me with this question or whatnot.
Uh-huh. Well, do you
And
see
then
where I
kind of
say
explained
you
it
can
back.
either do it with h or you can do it with a, it still cancels out? Do you see where I was talking about?
Yeah, it works both ways.
Okay. All right, let's do another. This is Ms. Castles. This is number 2, 3.1. And I'm glad you sent this question. No, this ain't the question. Okay, same type question. Is this the same one? It's different. I'm going to do it by the difference quotient. And then if you do f of x, if you throw in f of x, that's negative 3x plus 4. And you throw in a 2 for f of a, correct? Or 2, what would that be? Negative 2? If you throw in a negative 2, you're going to see they cancel out. And then x minus 2, that's going to cancel out. But like I said, I'd rather do f of x plus h. So negative 3, parentheses, plus 4, minus, brackets, 3x plus 4, negative, over h. And that's going to be x plus h, negative 3x minus 3h plus 4, plus 3x minus 4, over h. 3x's cancel, negative 4's cancel, you're left with negative 3. And the derivative of negative 3x, now that we know how to do the derivatives, is what? Negative 3. So the derivative is negative 3. Now, this next question, I'm glad you sent it. I think Ms. Wilson sent this question.
Yeah, some of my questions sent like 5 times because it wouldn't tell me it's sent.
Ms. Rudiger's did the same thing. She sent one of hers like 3 times. So I'll just look through it. It's the same one. Just tell me if you want me to go over it again or not. All right.
Okay.
The first thing I want you to do is graph this function. Take your calculators out, and I want you to graph this function. I'm fixing to show you where the first and the second derivative is going, where you're going to see this, not only with velocity and acceleration in physics, but you're also going to see it with increasing and decreasing functions, as well as the inflection points. So this is a good example, and I'm just going to kind of kill 2 birds with 1 stone here. First thing I want you to do is I want you to graph it. Second thing I want you to do is take the derivative. Now, this is 3.3. Does that mean calculus or algebra? Calculus. So you're going to use your power rule on each term. And you're going to get a quadratic. And then we'll take a from there. But go ahead and graph it. I've already graphed it on my handy-dandy calculator. Well, if I could get the handy-dandy calculator to come up. There's what it looks like. I'll move that over so you can still see the question. Now, draw a sketch of that on your notebook and draw it big enough to where you can put pluses and minuses along the line. So draw it big enough. And then take the first derivative. Why do people take pictures of themselves in front of a banner like they're movie stars and they're only in Podunk, Anderson, or Greenville and on the side of the sidewalk? Why do they do that?
Selfies.
Sounds like to me they're trying to project something about themselves that's not entirely true.
But it sounds like it's an upgrade from bathroom selfie.
Yeah, pretty much. I guess when you live in Podunk, Anderson, and Greenville, I guess you try to be like people in big city, I guess. I don't know. Now, when you take the first derivative, what is the first derivative? Well, there's several things the first derivative tells us. When you take the first derivative of this problem, you're going to get 6x squared minus 6x minus what? 120?
Yep.
And that's f prime of x. Now, the first derivative, not only with the speed and the acceleration in physics, the first and second derivative also gives us the increasing and decreasing values, and it also gives us the inflection points. So what do we do when we want to find the vertex? Well, what is the vertex? The slope is equal to what? What I tell you the slope is equal to at each vertex. I told y'all this in class. What is the slope of the vertex? 0. So if I wanted to find where the tangent of the slope of the tangent line is equal to 0, what would I set the first derivative equal to? 0. Dang old complete square. 6x squared minus 6x plus blank is equal to 120 plus blank. Factor out 6. X squared minus x plus blank is equal to 120 plus 6 times blank. Half of 1 is 1/2. 1/2 squared is 1 what? 1/4. And that's going to give us 6 times x minus 1/2, quantity squared, is equal to 120 plus 6 over 4, which is what? 3/2? Plus 3/2, that's going to be 240 over 2. So that's going to be 243 over 2. Somebody check me. 6x minus 1/2, quantity squared, is equal to, what'd I say? 243 over 2? Is that what I said? Yeah. Somebody check me.
That's right.
And then divide that by 2. Divide that by 6 over 1, which means you're going to multiply by 1 over 6. And that's going to give you x minus 1/2 quantity squared is equal to 243 over 16. Take the square root. What's the square root of 243?
12 over 12, right?
What?
Is it over 16 or is it over 12?
2 times, thank you, over 12. Thank you. I was trying to get a perfect square in there. Okay, so the square root of 243 over 12, I don't know what that'll give us. Let's see, that's going to be the square root of 243 over the square root of 12. The square root of 12 is 2 times the square root of what, 3? So that's equal to 2 times the square root of 3 over square root of 243, right? Somebody check my math. And then that's going to be square root of 243, square root of 243 over 2, right? Oh, 2 times 3 is 6, isn't it? Yeah, 6. That'd be a 6. Now, 243, I don't know. What goes into, doesn't 7, is it 7 or what goes into 243? I can't remember.
3 does, because it's divisible by.
Okay, well, square root of 3, well, let's do that then. Square root of 3 times square root of 3 times the square root of what? That's 81, right? Over 6. 3 times 3, I mean, that's going to be a 3. So that's 3 times 9 over 6. And that's going to be, I'm not going to be able to, that's going to be 3 times 3 times 3 over 2 times 3. So that's going to be 6. 3 times 3 is 9 over 2. I get 9 halves. But that's probably going to be a positive or a negative. Where's my, that would be a positive or a negative, right? Yeah, because the square root of 243 is going to be positive or negative. Somebody check my math on that. Somebody do it on your calculator. Some of you calculator drill team in high school, check it out for me. Somebody go to the vertex here and see what you get. 4.5. Positive and negative 4.5. Lord, I thought y'all were good with a calculator. I thought y'all could throw out numbers on a calculator like that gum 6-shooter. I'm just going to go over here and see if it's around 4.5. Yeah, there's 4.5 right there. And let's see if this is 4.5. Right there. Right there is 4.5. Right? 4.8, but somewhere in there. All right, the whole point is, somebody check my math and see if you get 4.5 on both sides. Okay, so that's A. So positive or negative 4.5. Now, what happens on the left side? So I'm going to just draw a line. I'm going to draw a number line right here. And I'm doing this to show you what the first derivative will give us. First derivative right here will give us, what I say, negative 4.5. So 0, 1, 2, 3, 4, 5. And 4.5 is right here. And then 1, 2, 3, 4, 5. 4.5 is right here. So 4.5 is right there. And negative 4.5 right there. So we set the denominator equal, but what do? Let's plug in a negative 6. Everybody with me? Negative 6. What happens when we plug in a negative 6 to our derivative? Plug in a negative 6 and give me f prime of negative 6. And tell me if it gives us a positive or a what? Negative. So let's do it in our head. Negative 6 squared is what? 36. 36 times 6 is what? 200? 196? Yes or no? Y'all supposed to be doing it with me. Okay. I guess I'm not going to get any help.
216.
Is it 216?
It's 36 times 6.
36 times 6, what is it?
216.
Okay, what's 216 minus 36? Doesn't matter, it's positive, right? Okay, go ahead and give it to me. What is it?
180.
How much?
180.
180? And what's 180 minus 120? A positive or a negative?
60.
It's positive, right? So what is this function doing up to negative 4.5? It's increasing. All right, now let's plug in a 3. Somebody plug in a 3. 3 squared is what? 9. That's 54. 54 minus 18. 54 minus 18 is a positive, but it's going to be a small enough positive. If you subtract that 120, what's it going to make it? It's going to make it a negative. So what is that function doing up to 4.5? It's decreasing. And then, of course, we see in the graph that goes off every 5 seconds, we see that the number is going to be what? increasing as soon as I turn it back on. There. And at 4.5, let's plug in a 5. Okay, 5 squared is 25. 6 quarters is $1.50. $1.50 minus, what did I say, 6 or 5? Minus 30. $1.50 minus what?
So it's, yeah, 130 minus, so you're still positive.
Still positive because it's a 0, or positive, so it's positive, so it's what? It's increasing. Okay? So the first derivative gives you the equation for the slope of the tangent line. I told y'all that a long time ago. The first derivative, f prime of x, gives you the equation of the slope of the tangent line. So if I want to find the vertex, I just set the first derivative equal to what? 0, because the slope at the, I'm trying to work here, I'm trying to be innovative, okay? The slope at the vertex is always going to be 0. Now what happens when we take the second derivative? Well, let's take the second derivative. Let's do the second derivative in red. I'm just going to do it above it. 12x minus what? And set that equal to 0. Well, you set it equal to 0, you're going to get what? Negative 6.
That's your one.
Be a positive 6, wouldn't it? Yeah. Should be 1/2.
You said x is 0?
I mean, y to 0, or your
okay.
derivative equal to 0. Hold on, baby. Why does this thing cut off every 5 seconds? Damn Russians. And basically, the second derivative will give you the inflection point. Okay, which we'll get into that later. Now, look at B. What does B say? Find all points on the graph at which the tangent line is equal to what? Negative 84. So what are you going to set the first derivative equal to? Negative 84. So let's do that. Y'all remember this. Negative 84, this is a good test question, whoever sent it. Negative 84 is equal to 6x squared, what?
Minus 6x.
Minus 120? Okay, now you can do this complete in the square, or you can do, it doesn't matter. I'm going to do it complete in the square just to piss people off. 6x squared minus 6x minus 120, and that's going to be, if you bring that over, it'll be a plus 84, right? Is equal to 0. And 6x squared minus 6x, what's negative 120 plus 84?
36. Negative 36.
36?
Negative 30.
Is that what y'all said? Okay, I'll do it. Nobody will reassure me. So 3 plus, yeah. That's 11 plus 1 is 120. Thank you. Appreciate the backup. 6x squared minus 6x is equal to 36 plus blank. Forgot my blank, sorry. Factor out of 6, you get x squared minus 6. Minus x. One of these days I'm going to figure out how to make my eraser erase. So wouldn't that be nice? X. See? Maybe 2050. I'm still hoping. But we have posters. Okay. Plus blank is equal to 36 plus 6 times blank. And what's half of 1? 1/2. 1/2 squared is 1/4, right? And that's going to be 6 times x minus 1/2. quantity squared is equal to 36. Well, that's going to be 3 halves again, so we're going to change this into 72 halves plus, I forgot, did I say 3 halves? 3 halves. So that's going to give us 6 times x minus 1/2 quantity squared is equal to 75 over 2.
Oh, that's 72? Oh, I guess we could.
What?
You're right.
And then that's going to be x minus 1/2 quantity squared is equal to, and I'm going to divide by 6 here, which means I'm going to multiply by 1/6, which is going to give us 75 over 12. Take the square root of both. And that's going to give us x minus 1/2 is equal to, and I'm going to go back to the square root of 75 over the square root of, or 2 times the square root of 3 multiplied by the square root of 3 over the square root of 3. X minus 1/2 is equal to square root of 3 times the square root of 75. I'm leaving everything open, just bear with me. Over 2 times 3 is what? 6? So I'm going to change this into what? 12/6? Or 6 over 12, right? 6 over, no, I'm sorry. 2, we're going to 6 3 times. 3 over 6. Whew. X minus equals the square root of 3 times the square root of 75 all over 6, and I'm going to bring that, what did I say, plus 3? 3. And then x is equal to the square root of 3, square root of 3, square root of 25, plus 3 over 6. Square root of 3 times 3 is 3, so that's going to be 3 times 5. It's going to be positive or negative 18 over 6, which is positive or negative 3. Somebody check my math. This right here is going to be positive or negative 5, which is going to make this, I mean, however you want to do it. 3, that's going to be 3 times positive or negative 5. Shoot. Hold on a second. Don't ask any questions yet. I'm still ciphering if I haven't made a mistake. 3 times positive or negative 5 plus 3 over 6. Now, what's 3 times positive 5? 15 plus 3 is what? 18 divided by 6 is what? What's 3 times negative 5? Negative 15. Negative 15 plus 3 is what? Negative 12 over 6 is what? Negative 2. So it's negative 2. So those are the two values that give you a slope of what? Whatever it said on the question. What was it?
Negative 84.
Negative 84. So the first derivative not only gives you positive, increasing and decreasing values, because it's given you at x is equal, at f prime of x is equal to 0, it's giving you the vertex. Because the vertex, the tangent line is always equal to 0. I mean, the slope of the tangent line is equal to 0. Capiche? Now, did you have to do completing the square? No. Can you just use the trace function? Yes. But that's not going to help you when somebody asks you to find the slope at negative, you could use the table function, yes. But when your bridge falls down and you get sued and you end up in a box, cardboard box in an alley, just remember me telling you this, okay? You've got to know the mechanics. You can't be on the calculator drill team and expect your bridge to stand up to whatever it stands up to, okay? Or your part, or your space shuttle, whichever the case may be. So you should probably just go ahead and quit. Who's got a question on that one? That first one might have not been positive or negative 4.5. You need to go back and calculate the positive or negative. It may be 4.5 and a little bit off of 4.5. I'm just going to put the answer in as 3, and then it'll say, I think the second one, the positive, I think is not 4.5. Yes, it's 5. It's not 4.5 because the negative throws a little wrench into it. So when I said -4 and 4, I meant something else. Next one. What did we say this one was? What did I say?
3 and, yeah, 3 and
3 and what?
-2.
I don't know how they're writing it. 3 and -2. Of course, that's not right, but should be 3 and -2. What'd they get? 3 and what? -2. Well, Hubert, how'd they get the -3? Well, what do? As soon as you get the point where they're equal to, remember I got x is equal to 3. What'd I get? 3 and -2? 3 and -2. These are both x's. Was it 3 and -2? This is x of 1 and this is what? That's x of 2. So you go back to the original equation and do what? Plug and chug. So that's going to be 2 times 3 to the third minus 3 times 3 squared minus 120 times 3 plus 5. Crank that out. And then what's the other plug and chug? -2. 2 times -2 to the third power minus 3 times -2 to the second power minus 120 times -2 plus 5. All right? Y'all crank those out on your calculators and see what you get. Who sent this question? Miss Gusmus or Miss Wilson?
Miss Wilson.
You did a good job, Miss Wilson. You just got a test question. That's a good test question. I do all kinds of things with that on the test. Does it help you that I went over it?
Yes, sir.
Go ahead and crank those numbers out and see if you got them.
Yes, sir. That's them.
Good. Anybody else have any trouble? Let's do another one. These are the kind of questions I like. I guess y'all call me weird. I don't know. What do you call somebody like geek? What? A geek? All right, is that different? Did that change it a little? All right, let's do that one. First of all, graph it on your calculator. And for those of you that can't see it, that sit on the back row, that's going to be f of x is equal to 2x to the third minus 6x squared minus 48x plus 9. All right, so go to it. Put it in the calculator. It's not going to be much different from the first one, but may have a different y-intercept or whatever. But make sure you sketch it so you can see what's going on. So the derivative, f prime of x, is equal to 6x squared minus 12x minus 48. Set that equal to 0. And now you have a quadratic, so you can 6x squared minus 12x plus blank is equal to 48 plus blank. And setting the first derivative equal to 0 is basically giving you your x coordinate for your vertex. Okay? Or you can set this equal to what? 0 and try to solve this. But what's the problem? This is a what? This is a third term polynomial. This is handcuffs and chains, okay? You don't want this, okay? So what you do is you take the derivative of it so you can find your vertex without having to deal with this the way that you would a quadratic and do what? Completing the square. So hopefully you're starting to see that calculus is not meant to be a burden. It's meant in some cases to what? Take the burden off of you, you know, in doing some of the more complex mathematical algebraic expressions. Okay? So have to sit or take 6 out. X squared minus 2x plus blank is equal to 48 plus 6 times blank. Hallelujah. 2 divided by 2 is what? Use your calculators. 1. 1 squared is what? 1. And that's going to give us 6 times x minus 1 quantity squared is equal to 48 plus 6 is what? 54. And now we're ready to, oh, this is sweet. This one is a very good test question.
Yeah, I like it.
Yeah, you like this one, don't you? Yeah, because you don't have to think, right? X minus 1 quantity squared is equal to 54. 54, therefore x minus 1 squared is equal to what? 9. Square root is x minus 1 is equal to positive or negative 9. What's 9 plus 1?
Positive, negative 3, you mean?
Yeah.
Oh, yeah, sorry. Okay, what's 3 plus 1? 4. There's 1x. And then what's negative 3 plus 1? And there's your 2 vertexes. Now remember, you just drew the whatever. I don't know what it looks like. It looks something like that. You just have the x's. So one is negative 2, and the other is positive what? 4. But you don't have the what? You don't have the y. So if you want to go back and get the y, you got to plug 4 back into what? F of 4. And then plug in f of what? Negative 2 to get your y's. And of course you can see if you plug in a negative right here, you're going to get a negative, like, I don't know, what's beyond negative 2? Negative 3? Negative 3, and you plug that in, you're going to get a positive because it's increasing. And then you're going to get decreasing, and then you're going to get, and then if you get the second derivative, f double prime of x, that'll give you 12x minus what? 12? Right? And that's going to give you can factor out a 12. So that'd be 12 times x minus 1. So basically your inflection point is positive 1. Look at there. That's your inflection point. And you can find that point by plugging in 1. So let's do 4. 4 cubed is what? 64? 64 times 2 is what? 128? Y'all check me. 4 squared is 16. 16 times 6 is what? 96? Minus 48 times 4. Dang old, I have no idea. What's 48 times 4? 50 times 4 is 200. 196? Or what is it?
192.
192? That's going to be minus 192 plus 9. So 128 minus 96, or 128 minus 100 would be negative 28, but it's going to be negative, I've got negative 32. Negative 32 minus 192 is negative 214. Negative 214 plus 9 is 205. Negative, what to do that? What do you get? Do the math. What do you get? You know, y'all should be hollering out these numbers. I shouldn't have to, you know, y'all should be doing this. Settle down, Pendleton. Y'all need to start drinking a Mountain Dew and coffee. Throw that bottle of dadgum water away and drink some dadgum coffee or some Mountain Dew.
Negative 151.
Okay, what did y'all get? Negative 151? I have no idea what. I must have done. Did I do something wrong? 128 minus 96. Yeah, I must have done something really wrong. What's 4 cubed times 2? What? What's 4 cubed? Isn't it 64?
64.
Okay, 64 times 2 is what?
128.
Okay, yes, you got that right. Okay, now let's do the second one. 4 times 4, 16 times 6. What is that? Okay, now let's check the third one. 48 times 4. That's the one I couldn't do in my head. Okay, and then 9. Now add all those up.
Those signs and stuff.
128 minus 96 minus 192 plus 9.
96 minus 192 equals 160, and then plus 9 equals 151.
Okay, did everybody get 151?
Negative.
Yeah, did everybody get that? Y'all see what I have to work with? I asked 19 people, did everybody get that? And I get 0 replies.
Yes, I have 151.
Thank you very much. Who said that?
It wasn't me.
Who was it?
It was Grant. Hello.
Mr. Hitt, was that you?
Yes, sir.
Thank you. You gonna be a winner. Your bridge isn't gonna fall down. All right, now let's do negative 2.
It may not fall down, but it will certainly burn.
Well, you know those bridges in Peachtree Plaza, they move with the wind. You know that, don't you? You
Thanks
know
for
why a
telling
bridge
me.
has to move, don't you? Dang old harmonics, dang old boots, dang old...
Yeah, I need to account
I
for
saw that,
oscillation.
there was that one video about the one bridge collapse.
Yeah.
That huge one. That was because
People were running.
after it got to a certain point, the wind started making it move.
Oh, the wind.
After it got to a certain point, then its own harmonics made the amplitude lined up.
Yeah.
and create the-
You ever seen the cue balls? You ever seen the cue balls on a string? Same thing.
It's crazy.
It is crazy how that happens. But you just have to, you know, people wonder why they can't get a job. Study physics and calculus, you'll get a dadgum job. Negative 2, plug it in, instead of global studies. So it gets me, these students, they go out here, they go to, first of all, they're from Podunk Anderson or Podunk BFE, and they said, I want to go to Yale. They ain't got no money. So they go out and they get all these student loans. They somehow get in, and then they go to Yale, and what do they major in? Underwater basket weaving, firefighting, global studies. Then they get out of this expensive college and they rack up $150,000 worth of student debt, and then they whine and complain to the government because they can't pay their student loan because they can't get a job in underwater firefighting, global studies. So then they just run for Congress. All right.
And then we elect them.
And then the DAs elect them, and then they stay on TV and everybody makes fun of them and they quit. And they put a stop to blonde jokes because they're so stupid. All right, so negative 2 is negative 8. Negative 8 times 2 is negative 16. Negative 2 squared is positive 4. 4 minus would be negative 24. 48 times 2 is negative what? 98. And plus 9. So that's going to give us negative 16 minus 24 is negative what? 40. Negative 40 minus 8 is negative what? 138. 138 plus 9 I lost it. Negative 128. Somebody tell me what that equals.
48 times 2 is 96.
Okay, I thought, okay, 96, thank you. So negative 16 minus 24, negative 40 minus 96 is negative 138, 136. Plus 9 is what, 147 or I go backwards, 127? Negative 127, did you get that?
Yes.
So
I got 90. I got 97 because the negative 96 should be a positive 96.
You're right, thank you. Okay, what'd you get?
97.
97. Okay, so there's your 2 points. 4, negative 151, and negative 2, 97. Now I want you to set it equal to 42, and that'll be the last part. Set the slope equal to 42. So you're going to come over here, and you're going to set this guy equal to 42. So do that. So now I'm going to set it equal to 42, because that's what it says to. So 6x squared minus 12x minus 48 minus 42 is equal to 0. 6x squared minus 12x, what is that? Negative what? 90? So bring it over, it'll be a what? Positive 90. 6, I'm going to just factor that out. That'll be x squared plus 2x or minus 2x. I'm just going to erase that. Trying to save a little bit of room and time. Okay? There we go. And that's going to be 6. 6 times x squared minus 2x plus what? 2 is equal to 92. No, that's not right. That's going to be 6. I'm skipping 2 or 3 steps, so just hold on. 6 times 12 be 102. That's going to be 6 right here, and then 2. That should be 102. What's 90 plus 12? 102? Should be. And that's going to be 6 times x minus 2, x minus 2, no, x minus 1. Quantity squared is equal to, wait a minute, something's wrong.
It's plus 1.
X, no, it'd be minus right there.
No, I mean,
Half of 2 is 1. 1 squared is 1. 1 squared is 2, y'all. Stupid. 90 plus 6 is what? 96? I called it, so y'all didn't. You're supposed to say, oh yeah, I thought that's what it was. That's what everybody's supposed to say. Plus 96. Usually Miss Gusmus and Miss Wilson keep me on track. All right, so what does that come out? What's 96 divided by 6? Dang old 16? I don't know. Somebody check me and tell me.
Yeah.
Okay, so plus or minus 6. So that's going to be positive 6 plus 1 is 7. Negative 6 minus or plus 1 is what? Negative 5. Y'all check me and see if that's what y'all come out with.
6 divided by 96, 16.
96 divided by 6 is
Sorry.
16. Or, no, that's a, okay, square root 16 is 4. I'm sorry. Square root of 16 is 4. I'm skipping too many steps in my head. 96 divided by 6 is 16. Square root of 16 is 4. Positive negative 4. 5 and 3. Yeah, thank you. 5 and negative 3. Is that what y'all got? Now remember, is that x and y, or is that x sub 1, y sub 1? I mean, x sub 1, x sub 2. That's your two x's. So you got to plug them back into your original to find your y coordinate for the tangent line being what? 42. Okay, so y'all did good with those two test questions, because if you know how to do those two test questions, you know pretty much how to do everything except for the chain rule and the product rule. That's a good question for 3.1 and 3.2. So
Before the end of the class, another product rule one.
yeah, we can try right quick. Let me see if I can find one, or just you got one in mind? Okay. Product rule. Let's hold on a second. Let me pull one up right quick. Some of y'all, I know it's 3 minutes, and I know you're going to go into convulsions, but you'll be all right. If I could ever get the thing to work. Let me just go to the homework. Somebody tell me what 3.1 is. Is that homework? Is that? Anybody know right off the top of their? Y'all settle down. Don't answer all at one time. I can't understand you. I hope y'all are not like this at home.
I think there's a homework specifically listed. Probably.
Okay, good. That's what I was thinking. Hold on. Let me go to assignments. Product rule.
I am absolutely like this at home.
Right here. Product. Chain rule or product rule?
Chain.
Chain rule?
Because chain rule does product rule in it, right?
Well, yeah, it depends on the problem. I don't know. Let me find one that has. Okay, that's just chain rule. That's just chain rule. Chain rule. Wait a minute. Yeah, that's quotient. That's chain rule. That's chain rule. That's quotient rule or chain rule. No, wait a minute. Let me just go to the. Do you want chain rule or quotient rule? I mean, product rule. You want product, right? Okay, well, let me go back and do the product rule. It's easier for me to find a product rule than trying to find a nested one. And I don't want people to, pass out, so we can do one right quick. Okay, there's one right there. There's a product rule. It's one of the easier product rules. Why?
Because x.
E to the x. What's the derivative of e to the x?
E
E to the x. So this is a real easy one. The one I'd give you on the test, just to see how many people would miss it. So, how do we do it? First, since it is multiplied, first times the derivative of the second, and I'll put it in blue, plus the second plus the second times the derivative of the first. So 3x squared minus 6x plus 6, and the derivative of e to the x is e to the x. Now what's going to happen is you're going to factor out e to the x in your answer. Plus e to the x times 6x minus 6. And then that's going to give you e to the x parentheses 3x squared minus 6x plus 6 plus what? 6x minus 6. And what happens to the 6x's? Oh, this is a good test question. 6 and 6. So your final answer is what? 3x squared e to the x. And you can write that e to the x times 3x squared. Or you can say 3x squared times e to the x, but I would put that in parentheses maybe. So. Okay, now we're going to go ahead and cut off class, not now, because I'm 2 minutes over and I don't want anybody to do cardiac infarction. So let me cut the recorder off.